Okay, next we will go into solve one problem, and here the question is given a random sample of size 1 from distribution with the density f of x theta equal to theta into x to the power theta minus 1 if 0 less than x less than 0, 0 otherwise. For testing h naught theta equal to 1 versus h1 theta equal to 2, construct most powerful test for testing h0 versus h1. Obtain the power of the test. Is the question. Here we need to construct a most powerful test for testing h0 versus h1. And also here we need to obtain the power of the test. Right. So here is given that the size 1 and also is given the density. Right. So we will solve this problem. Right. Here is size 1, right? So we have to take the density. Here density is given, right? That is f of x theta equal to theta into x to the power theta minus 1 if 0 less than x less than theta, right? But here under h naught theta is equal to 1 and h1 theta equal to 2, right? Here under h naught, what is density? F naught of x equal to theta equal to 1, right? That is 1 into x to the power 1 minus 1, right? If 0 less than x less than theta is 1, right? And it's not, is 1, 0 otherwise, right? Then under h1 is f1 of x equal to, under h1 is given that theta equal to 2, right? Then what is the density? That is 2 into x to the power 2 minus 1 if 0 less than x less than 2, 0 otherwise, right? This is the density under h0 and density under h1. From the Lyman-Pearson lemma, we reject h0 for the Laurent's ratio, that is f1 of x divided by f0 of x, right? But here the ranges are different, right? Here 0 to 1 and 0 to 2. So we have to split these range, then you can rearrange this density, rewrite this density, right? That is under h0 f0 of x equal to, what is that? 1 into x to the power 1 minus 1, that is x to the power 0, right? Is equal to 1, right? If 5 power 0 equal to 1, right? So like x to the power 0 is equal to 1, right? Then f naught of x equal to 1 if here 1 into 1, right? That is 1. If 0 less than x less than 1, if 0 less than x less than 1. And also here we need to split this term, right? We can write this term as 0 less than x less than 1, 1 less than x less than 0. Same, right? We can split 0 less than x less than 2 as 0 less than x less than 1 and 1 less than x less than 2. Okay, so here 0 less than x less than 1. So then we have to write if 1 less than x less than 2, right? Here in null hypothesis f naught of x equal to 1 if 0 less than x less than 0, 0 otherwise, right? So here 0, right? Then 0 otherwise. Then under h1, that is f1 of x equal to, here 2x power 2 minus 1 means 1, right? That is 2x if 0 less than x less than 2. So here we need to split the terms, right? Split the range. So then we have to write 2x into, 2x if 0 less than x less than 1, and here is 0 to 2, right? Then if 1 less than x less than 2 is also 2x, right? 0 otherwise. Alright. So from Lyman-Pearson lemma, we reject H0 for Laurent's ratio, that is from Neyman-Pearson lemma, we reject h naught if f1 of x divided by f0 of x is greater than k. Right? Then what is of f1 of x? The ratio, that is f1 of x divided by f0 of x. So we need to divide, we need to take the ratio of this f1 of x and f0 of x, right? First we will write the ranges, right? Then we write the ratio, right? The first range is if 0 less than x less than 1, if 1 less than x less than 2, and otherwise, right? f1 of x when 0 less than x less than 1 is what is that? 2x divided by 1, right? That is 2x. Then here if 1 less than x less than 2, that is 2x, 1 less than x less than 2, 2x, here 0, right? This 2x divided by 0 is equal to infinite, right? Then here 0 otherwise, right? So here we need to find for which value the ratio is greater than k, right? For maximum. For that we have to make a graph, right? That is like here the f1 of x divided by f0 of x. Here it takes the value of x, okay, the value of x. Then it's a 2x, right? He will take the ranges 0 to 1, 1 to 2, 2 to infinite, right? Here 0 to 1, 1 to 2, 2 to infinite, okay. Then here 0 to 1 it's 2x, right? Which means it's an increasing function, right? 2x. So 0 to 1 is a increasing function, we take this, right? Then 1 to 2 is a what is that? 1 to 2, 1 to 2 is a infinite, right? There is a large value, we take infinite. 1 to 2 is a infinite value, right? So we know that we reject is not for the large ratio. So here infinite is the large value, right? The maximum value. So this is one of rejection region, that is 1 less than x less than 2, right? And also we need to find for the which value this takes maximum, right? So here this is a maximum, right? So we will take this as a k, okay, this is k. Then what are the rejection regions here? That is the rejection regions are here k, here x, right? This value less than x less than 1, or these 1 less than x less than 2. These two are the rejection region, right? Then you will write the test function. It is a test function for testing h0 versus h1 is phi of x, because here the single sample size, right? The sample size is 1. For that we have to take phi of x, right, equal to 1 if the rejection region, that is k less than x less than 1, or 1 less than x less than 2, then 0 otherwise, right? So for then we have to find out the size of the test and also power of the test. All right, what is the size then? Size of the test, that is expectation of phi of x, right, which is equal to alpha, which implies 1 into probability of k less than x less than 1 or 1 less than x less than 2 equal to alpha, right. Then we can write these term as a probability of k less than x less than 1 plus a probability of 1 less than x less than 2 equal to alpha, right, which implies here under h naught probability of 1 less than x less than 2 is what is under h naught, or f naught of x is 1 less than x less than 2 is 0, right. Then this time is 0, that is, then we can write this as probability of k less than x less than 1 equal to alpha, right. That is, which implies integral over k to 1 f naught of x dx equal to alpha, right. What is f naught of x? What is f naught of x? F naught of x is 1, right. If 0 less than x less than 1 is 1, right. It is integral over k to 1 into dx equal to alpha, which implies x k to 1 equal to alpha, right, which implies 1 minus k equal to alpha. Here we need a k value, right, that is then what is that? 1 minus k equal to 1 minus alpha, right. Then 1 could cancel here, it's 1, that is k equal to 1 minus alpha, right. Then we want to find the power of the test, right. What is the power of the test? Power of the test is the probability of the test, probability of rejecting H naught when the alternative hypothesis is true, right. That is a beta equal to expectation of phi of x under alternative hypothesis h1, right. So here it's equal to probability of k less than x less than 1 or 1 less than x less than 2, right. It's equal to, you can write that as, is equal to probability of k less than x less than 1 plus probability of 1 less than x less than 2, right, which implies is equal to, so here you can write this term as integral over 1 minus here k, right, k to 1. So here we know that k value is 1 minus alpha, right. Then we can write 1 minus alpha to 1 f1 of x dx plus here 1 to 2 f1 of x dx, because power of the test is under h1, right. It is equal to, what is the f1 of x? f1 of x is 2x, right. It is the integral over 1 minus alpha to 1 2x dx plus 1 to 2 2x dx, right, it's equal to, so we need to integrate this term, that is 2x square minus, sorry, x square divided by 2, right. 2 get cancelled, then 1 minus alpha to 1 plus here also, that is 2 square 2x square divided by 2, right, 1 to 2 dx. Then substitute the value, that is equal to here x square, right, 2 could cancel here, 2 could cancel, the remaining x square, that is x square 1 minus alpha to 1, sorry, 1 to 1 minus alpha, that is here also x square 2 to 1, right, which equal to 1. Here we need to substitute these values, right, 1 and 1 minus alpha, 2 and 1, that is 1 minus alpha square, right, plus 2 square minus 1 square, right, here also square. Then that is a 1 minus alpha square plus 4 minus 1 is equal to 1 minus alpha square plus 3 is equal to, what is that, 4 minus 1 minus alpha square, right. This is the power of the test. When if alpha is equal to 0.05, then what is beta value? Beta equal to, substitute the value, then we can get 3.07 3.0975. Okay, so which implies beta is greater than alpha. What is the power of the test? Power of the test means it's a probability of rejecting H naught when alternative hypothesis is true, right? We know that the probability lies between 0 and 1, right? Here, but here beta is greater than 1. This is due to the improper density under H1. Okay, here beta is greater than 1. This is due to improper density under H1. Okay, because the probability lies between also always 0 and 1, right? But here it's greater than 1, because this is due to the improper density under the alternative hypothesis. Then this power of the test is wrong, right? Because under the alternative hypothesis, the density is improper.